Hello and welcome to another Solana tutorial. I tell you, there are so many things happening in the Solana ecosystem, and it's impossible to keep up with everything. And even with the things that I know about, it's tough to keep up. Like, there's a new candy machine v3, there's Backpack that I want to look into. But today, I want to talk about versioned transactions. Yes, let's do that. Because from all the topics that are burning right now, I think this one is the most relevant or important, at least for me, because it's the one which has the biggest impact, I think. Specifically for Solana devs, that is. You know, if you're an NFT person, you don't really care that much about that, but we are devs here. So I do want to look into this. Because if you recently went to the Solana Explorer and check out how smooth it runs all the time with 3,000 to 4,000 TPS. Anyway, then you might have also noticed that when you look at any transaction, let's see, any transaction. How do I find any transaction? Just check out the current slot. There will be transactions there. So maybe pick one with success. Then what you immediately see here is this transaction version, which is legacy. So they added this new field here in the Explorer. And this is because there are different types of transactions now. Legacy is the old one that we all know, right? That's what we grew up with. That's the normal transaction. But then there are other ones, because we have transactions v2, which is slightly confusing because the version 0 is this new transaction. Maybe I find a new one, or probably most of them are still the old ones, so I don't think I'm gonna find one by randomly clicking somewhere. Anyway, so most transactions are still legacy, but we're gonna create version 0 transactions today. But before we do that, we want to go through some theory. Here I'm in the Solana documentation. In the accepted proposals, we have the transaction v2 on-chain address lookup table. Right. So starting with, why the hell do we even need that? Well, you might remember that there's a transaction size limit, which is annoying for some things. Many things actually. Even for my fee redeemer, remember this thing? There. I have to split it up in several transactions, and that's why I say here how many transactions you need to sign to redeem all of that, because I can only put so many accounts into one transaction. I think the limit I set here was 16 or something. I don't remember. Somewhere in that range, I had to limit the amount of accounts I can close at the same time because of transaction size limits. The interesting thing though, now when reading this, now I finally understand why there is a transaction size limit. It's because of the MTU size of IPv6 packages, which is funny because I was literally just at university. I was teaching them about IPv6 and the MTU size, and haha, cool stuff. Anyway, so basically you can't make an IP package that is bigger than a certain size, like the data must not be more than this. And then we also have some headers, so the actual transaction size can only be 1232 bytes, because that's all we can fit in there. So we still keep it one IP package because we were using UDP. So we just send one. There's no several package that we then put together. Anyway, for technical reasons, we have a max transaction size. And so when you want to work with like more data, like say you want to just send a lot of data, then you need to have several transactions, right? When you store stuff into the candy machine, or even when you deploy a program that doesn't fit in one transaction. That's why we create a temporary account and put all our data there in several transactions, such that we can then use it all at once. However, the problem with this is it's not atomic anymore. Atomic meaning it happens or it doesn't happen, because each transaction is atomic, but if then one of them fails, then you need to roll back all of the other transactions by doing more transactions again. So, it's not atomic. Right? And mainly we want to add more addresses, right? Those are 32 byte things. A public key is 32 bytes, as we learned in previous tutorials. that you all watched, of course. So until now, we didn't have a good workaround, right, to increase the number of accounts that we can put into a single transaction until we introduced transactions v2 and lookup tables. So 35 accounts approximately is what fits in there. Let's see, 32 divided by 32 is 38 plus a little bit more that you need for signatures and other stuff. So 35 accounts is what we can put in. So theoretically, my fee redeemer could support up to 35, closing 35 accounts theoretically, if I wasn't also using the program to count how much has been redeemed, which 586 sol is not nothing. Good job, guys, making all that money back. The proposed solution and the accepted solution, because this has been a proposal and it's now already been accepted. So this is already in place. There's a new program which manages lookup tables. By the way, if you want a good introduction to this topic, go to YouTube, Solana, Bytes, and then you will find this video about transaction v0 and lookup tables. That gives you a good basic understanding of it. John did a really nice video on that. Nice and short with 8 minutes, which is long for Solana Bytes, short for my videos. And then there's now a new transaction format, which can make use of those lookup tables and load accounts more efficiently in one transaction. So essentially we create a lookup table where we say this account, this account, this account, this account, and then we create a transaction where we just say account number 1 in the lookup table, account number 2 in the lookup table, account number 3 in the lookup table. And since we then, I haven't actually read this, so I'm just assuming that what stands here, referenced by a 1 byte U8, so we just need 1 byte anymore instead of 32 bytes per address. This will require a new transaction format to make use, and that's how we can then potentially use a lot of addresses in one transaction, right? So it's factor 32. So theoretically, 32 times 35, up to 1,000, does that make sense? No, up to 256, of course, because we have only 1 byte to reference it. Right, so 256 addresses is max. But can we also do that and manually add addresses? I don't know, but would only add, a few, because we then need the 32 bytes again. Anyway, state address lookup tables must be rent extend when initialized. So essentially, we put an account on chain again, right? So with that program, put some data on chain. So this is again something that we need to do up front. So again, not perfectly atomic, but just putting the addresses there, I guess, not much loss. When initialized and after each time new addresses are appended, lookup tables can either be extended from on-chain buffered list of addresses or directly by appending addresses through instruction data. Newly appended addresses require 1 slot to warm up before being available to transactions for lookups. Okay, this is interesting as well. 1 slot to warm up. So 400 milliseconds. Okay. I forgot how many slots there are in an epoch and whatever, but we're talking less than a second. Okay, good. I mean, we can afford that. Good, 400 milliseconds. We can't do it like in the same slot, like super at the same time. This is the address lookup table and now do my transaction. We need to wait 1 slot, which makes sense. Kind of, we need to wait for it to be confirmed. Address table accounts also tracks various metadata. Okay, so let's look at this in detail. Can store up to 2 to the power of 8 addresses. Oh, the meta size is 56. Okay, yeah. Okay. Lookup tables cannot be closed until the deactivation slot. Okay, so there's a deactivation slot. How long it's valid, probably. The slot the table was last extended, obviously, because we need to wait for the next slot until the thing is valid. Yeah, we're extended before, right? So only if we're not on the same slot anymore, we can use it. So that makes sense. Last extended slot start number. Start index where the table was extended, so probably the offset. We need to kind of track the offset where to put the next address if we want to add another one to the table. And an authority that must sign if we modify it. Makes sense, but it's optional, so apparently there can be public lookup tables that anybody can or nobody can. Not sure. Probably more nobody if there's no authority anymore. Because if everyone, that just does not make sense. Padding to keep addresses 8 bind aligned. That's also funny. We put some padding such that we then start at a multiple of 32. Because those apparently add up to 54. Let's see. Now we can calculate how big a slot is without even looking it up. Because an option of a pub key is 32 plus 1 bytes. So that's 33. another byte for this U8. So that's 34, which, 54, 34, which leaves 30 bytes for 3 slots. No, for 2 slots. 2 slots? Let me count again. 1, 2. Yes. So that must be 15 per slot? That does not make sense. It makes more sense that it would be 16 bytes. Yeah, I'm getting sidetracked, but I love to get sidetracked because that way you learn, right? Makes the video longer, but hey, if we understand stuff about how slots are represented, slot size in bytes. Can I find it out like that? Slot, the period of time, it's each leader, just transactions to produce a block. Create a logical clock, non-overlapping. So a slot, for instance, is this. Right? So those are slots. What size is that stored with? I don't have it in the space reference, do I? I would assume that it's 16, because 15 is just not a nice number in computer science. Probably I miscalculated something else. So if we had 16 twice for the slots, plus 1 byte for the start index, plus 33 for the optional pub key. That's 66? I really can't calculate. Hold on. Where was my mistake here? Oh, that's 20. So maybe a slot is 10 bytes. Maybe. I don't know. Why is that so hard to find out? Anyway, we've got 2 more bytes padding in any case, such that we get to 56, because 56 is divisible by 32. No, it's not. Whatever. So that's the data that is in there. The padding is just not used. It's just the 2 free bytes. Okay, moving on. To make it easier for address lookup tables to be updated by multisig or governance-controlled authorities, addresses can be buffered on-chain in a buffer account. Details that I judge not to be that important. Once the address lookup table is no longer needed, that's more important because that can happen quickly. It can be deactivated and closed to have the rent reclaimed. Same way you close token accounts, you can close those lookup table accounts. But they may not be recreated at the same address because each new lookup table must be initialized at an address derived from a recent slot. So when finding the address for a lookup table, the address where you store the address lookup table, apparently you take a recent slot as a seed, and therefore you can't have the same lookup table anymore, which is fine. Address lookup tables can be deactivated at any time, but can continue to be used by transactions until the deactivation slot is no longer present in the slot hashes sysvar. Okay, so there we would need to know a bit more what or how many slots are in the slot hashes sysvar. But anyway, essentially, when you deactivate it, there might be a few slots cooldown period. In-flight transactions cannot be censored, right? So again, security. But we don't need to go into too much detail here. Since address lookup they require overhead, they should incur higher costs for a transaction. It doesn't say how much higher, but it has higher costs. Okay, fair enough. Makes sense. Makes perfectly much sense if I can do 4. So that leaves me 4. So it's factor 32. Because 32? Nah, it's not. 2 to the power of 4, 5, 6, 5. Oh, 5. Factor 16. 32 times 16. No! God damn, it's factor 8, you idiot. Do this calculation in the first place. Anyway, so it's factor 8 how many accounts we can have, so we can potentially do factor 8 as much. Then there's also the limit with the compute, but still, it makes sense that they are more expensive. So, version transactions. I still want to figure out why it's called versioned transactions. Is that because we have different transaction types now, so we need to say which version of a transaction it is? In order to support address lookup tables, the structure of the serialized transaction must be modified. The new transaction format should not affect transaction processing in the Solana program runtime beyond the increased capacity of accounts and program invocations. Involved programs will be unaware of which transaction format was used. So apparently it's about the format, so the new format. So we have a version for which transactions is, I guess. The new transaction format must be distinguished from the current transaction format. Current transaction can fit at most 19 signatures, but the message header encodes as a U8. Since the upper bit of the U8 will never be set for a valid transaction, we can enable it to denote whether a transaction should be decoded with the version format or not. Aha, so they found a place in the transaction that is never used, and they now use it for the version. Okay, fair enough. Making it backwards compatible. And since we never really looked at the old transaction format, not sure how much it makes sense to look at the new transaction format. So this is important. We have the legacy, so that's the ones that we use or that we used to, and then we have the v0, that's the ones with the lookup tables. Actually never looked at this before. Address lookup tables, so it's a vector of message address table lookup, and this message address table lookup consists of the public key of the address to the address lookup table, and then the list of writable accounts, so that's a vector of u8, and then the read only, another vector of u8, and there we use the indexes, whatever, the numbers of the element in the lookup table. Cool. 1 extra byte for version field. I thought we found a place in there. Hold on. What does that say then? I thought we saved that byte. Anyway, yeah, we don't need to go into too much detail here. Maybe look at the limitation. I'm looking like this. I don't want to read. Address lookup tables can only hold that many elements. Also makes sense because, I mean, if we put in more that we can't reference, that's just pointless. So for the signers, we must provide the address directly in the transaction. That transaction signature checks. Don't need to look it up. Okay, cool. Hardware wallets will probably not be able to display details about account referenced from the lookup table, and there are no recursive lookups. So we can't put another address lookup table into our address lookup table and then let it recursively look. Nope, that's not how this works. Okay, and then there are some security concerns that are discussed here, and I don't want to go into those. You can read that up yourself. So we basically know the details about what that's about. We have a new format for transactions, v0, that take an address lookup table instead of the raw accounts. Let's see what that looks like in practice. Let's work on an actual program that we can make better with v0 transaction. And what better program to improve than my own fee redeemer? Let's go to my fee redeemer and clone that. Git clone this, because I don't know where I have it on my computer, so we just clone it. And then we open it in here. That's probably better. Yes, I trust the author. The author is a great guy. So my max close instruction I put to 15, and maybe first let's play around with that and break it. So, well, first I probably need to yarn install all the packages. I hope that still works. It's an old program. And then I would like a script that just creates empty token accounts for me. Can't be too hard. Okay. Should we just create new tokens as well? Because it doesn't really, we're indefinite, not like we really care. On mainnet, I wouldn't do it like this. I would get myself a list of existing tokens. Load key pair, and then let's create a new one. There we go. Solana config set defnet and this key pair, just in case we need that, and then do a quick airdrop of 1 sol. There we go, just so we can work with this. So we create a mint, and then we need to also create the accounts manually. You know what, put it in a transaction right away. You know what, F this, we're gonna make it in 2 steps. I create mint, and then we get the pub key. Just await this, that's fine. Let's put it in 2 transactions and we await those 2 things. Much easier, right? Let's see if it works for 1. Do I have different versions of the stupid SBL token library again? Apparently. Oh, this is annoying. I'm using the very, very old version. And if I change the version, then I'm gonna get problems all over my fee redeemer, and I basically need to rewrite all of this stuff, which I kinda also don't want to do. See, because it doesn't have the token. But hey, hold on. Is that how you did it back then? Alright, we're gonna update. This is gonna F everything. Everything! We are in version 0.35. You are in version 0.18. Okay. What could possibly go wrong if I update now? Gonna ruin the entire thing. Meanwhile, I can fix this. NFT mints using old versions will be disabled tomorrow. No, today. Interesting. Solana Gateway React. Stuff changes so quickly. Anyway, there are also 24 high and 10 critical vulnerabilities. Oh, what could possibly go wrong? Okay, but now at least it seems to work. Had to move it way out, but whatever. And it created me an empty token account. If I now, there we go, we're in DevNet. And if I now connect, because I don't have an logout button. Maybe that's something that I also need. There we go. The wallet that just connected. And on mainnet, there's nothing. But if we start the fee redeemer locally again, and I hope that still works after I updated SBR token, but I'm afraid it might not. This is taking long, yo. Failed to compile. Just clone it and start it. Did it also already not work? Or is that a new thing that I now messed up? We're gonna find out after installing all the packages. Maybe we're just getting ahead of ourselves here. Maybe we should start just using the address lookup table in a very local example. And by local, I mean like small example. Because it seems like I can't even get my fee redeemer to run. Great code I wrote, great code. That's the problem if you don't know how to front end develop and stuff changes quickly. Then you're essentially screwed. We still have feed, we can still run. Let's run away from this. I mean, audio feed I meant, in case you don't find that funny. Oh, come on. If it doesn't work, then at least tell me quickly that it doesn't work and don't let me wait here. Yeah, there we go. At least that compiled successfully. Good. Cool, so we do get the fee redeemer to work. Right, if we now connect, that's always our problem because we're on mainnet. Haha. I want this now. Nope. That's all we change. Oh, and then we probably also killed it, right? So start again. And then let's also just use a second one of these. Just play with version transaction. On DevNet, not that much has been redeemed. There we go. With this account, I can close one in one transaction. And let's use our script to create a bunch more. Let's see how many I can do before getting blocked. We're in DevNet. I don't care about creating new tokens. Oh no. I did too many. Connection refused, so apparently we're blocked here as well now. Oh, can't even create 20 empty token accounts without getting blocked. I can't work like this. Won't let me connect anymore. That's not even what I want to do. I want to play with version transactions, and I've been playing here with like for another hour. I'm unblocked already? Yes. 3 I could still do in one transaction. Well, let's do them sequentially. This is gonna take a shit ton of time, but at least the RPCs won't block me anymore. I mean, we can let that run while we play with transactions. Let's start a new file. We just want to have 6. We just want to play with transactions, V0. Because I already don't even know how I would do this, right? How do you build an address lookup table? There's the issue for it. We can have a look at the program. Stack Exchange has something. And of course, there's the Solana Bytes video. Let's see if James, sorry, this is John. Joe, sorry. So many J's. This is Joe. Put his code in a GitHub. Isn't that nice? And essentially create an address lookup table. Address lookup table program, create lookup table. I mean, can't be so complicated. And the address lookup table program is in Solana Web 3. So import this. Okay, cool. And then we see all the things that we can do. Close lookup table, create lookup table, deactivate lookup table, extend lookup table, freeze lookup table. Nice. So first we create one, then we can extend it to make it bigger. We can deactivate it, and once it's deactivated, we can close it. We can probably also freeze it to make it not usable anymore or something. But staying with the easy stuff. Creating a lookup table. This takes create lookup table params. An authority, a payer, and a recent slot. Yes, copying code, because we're gonna have my key pair again, which we load like we did here. And then the authority is gonna be my key pair. Public key probably. Or what does authority need? A public key, yep. Perfect. What else? A payer, well, I can pay, I have money, we're on DevNet. And a recent slot. Now this is the most complicated, because this we need to get from Jane. As we read earlier in documentation, when you derive the account for an actual address lookup table, you need to put in a recent slot. So that's what it needs here. And we can get that from a connection. So let's get ourselves a connection. connection get slot, the current slot. Cool. Probably need to await this. Okay, and with that, we can create an address lookup table. So this just creates a lookup table, nothing more. What can we then do with this? Hold on, what does it return? A transaction instruction and the public key. So probably the public key is the actual address for the address lookup table, and the instruction is the instruction that I need to send, because this will, oh wait, how in a, okay, so we do the instruction and the address lookup table address alt. Okay, now how do we actually get addresses into this address lookup table? With a program extend. So apparently first we need to create, then we need to extend. I'm not sure if we can do that in the same transaction. We're just gonna try, and the worst thing is we get an error. So what do you need? Addresses as a public key array. Okay, array of public keys, gonna do that in a second. Authority, that's me. Lookup table, that's the alt address, or should we call it lookup table address? And the payer, okay, that can also be me. Now the addresses I want to put in, the question is, what do we do here? We can do a simple send something from somewhere else. I don't know, do a token transfer from some tokens. Let's pick some random addresses from down here. There, I'm gonna pick this one. Gonna counts. This one looks fun. And this one looks fun. Because we could, for instance, SBR token mint. Actually, let's just use one token. Let's just use this, the mint. For this one, we actually mint 3 tokens, and then const ATA. So we have the mint, we have the associated token account, and then a receiver token account. For that, we need another address. Who do we send it to? Here. So we can say SBR token create account for this token for owner Andy, and then we create this account, and this one is the receiver ATA. I'm getting faster at typing this stuff. Cool. There's some manual work while we're creating some more tokens here. So we want to send this mint from here to here. So we put in those 3 things, the mint, the ATA to send from, and the receiver ATA. And what we get back here is another instruction. This is extend. And now we have a create instruction and extend instruction. I can put all of that into a transaction. I'm wondering if it works. If I were to just create a normal transaction with a transaction, my signers is just my key pair, I think, and no options. Do you think that will work? Let's see. We've created a few token accounts. See, now that I can load them again. 32 empty token accounts, and with my current setup, it would take 3 transactions. Not gonna deal with that now though. We are gonna check if this txv0 script executes. No, it does not. This is not a recent slot. I mean, we are at slot 168763. Maybe it's just a bit behind. Let's try again. Oh, now that looks better. Okay. So we've gotten a transaction out of this, a signature. Let's check it out. It's a legacy transaction because I didn't use a new one. So also with legacy transactions, you can create address lookup tables. We did a create lookup table and we did a extend lookup table. Both of them apparently went through in one transaction. Looks good. I don't like the new colors here, but yeah, whatever. So cool. We spent some money on an address lookup table. Fine. But now we can use it, hopefully. So that was a create lookup table. Now let's do a use lookup table. And what do we do here? Essentially, we want a transfer instruction from the token program. So we import from SPL token, create transfer instruction. And here we basically use the same things as we would make a normal legacy transaction. Source is the associated token account, destination the receiver token account, owner is my key pair. Wait, what's the owner? Yeah, that should be my key pair. Amount, let's just say 1. We have no decimals, like 0 decimals. No multi-signers, no default token program. So that's the instruction I want to send. But now how do we do it using the address lookup table? And I'm once again gonna cheat a little bit and look here. Oh, I should have probably stored the lookup table. Hold on. This one is my lookup table now, right? Gonna copy this. Const lookup table, just for fun. So we need, okay, so we need a version transaction. I want to see if I can figure out the rest myself. So we need a version, not in my version of Solana Web 3. So guess what we're gonna do? We're at version 1.65.0. This one has a version transaction. So I wonder why I cannot import this. Solana Web 3 has no exported member version transaction. I never know which version of Solana Web 3 I'm currently using. So this is a bit annoying, admittedly. Cannot just be npm. It's gonna install Solana Web 3 again. There we go. And then it suddenly works. But then I don't have to send transaction anymore because that's deprecated. Send transaction with a version transaction. Cool, a version transaction. So apparently we're not supposed to use transactions anymore. Just do a version transaction here. This requires an argument for message was not provided. Leave it like that. Let's find it out here. Message. An argument for message. You need a message, a versioned message, and signatures. Okay, what's the versioned message? What can that be? You know what? I'm gonna just cheat again and look at the code. Message v0. The hell is that? Message v0 is a transaction message. You know what? I should have looked at the Solana Bytes video again. So compile to v0 message. Okay, fine. So let's make a new transaction message with transaction message args. Great. And they need instructions, payer key, recent block hash. Okay, that I can do. Instructions is just a list of my one instruction. Payer key is just my key pair. Payer key needs to be what? Public key. Okay, then my key pair dot public key. And then what else? Recent block hash is connection. Get recent block hash we should not use anymore. Get latest block hash. Okay. Get latest block hash it is. And that we await. Is that okay then? Latest block hash gives me the block hash and the latest valid block height. Okay, and then I just get the block hash. Okay, cool. And that's still not a versioned message because we need to say compile to v0 message. Then we have a versioned message, and that message we put into the version transaction. Okay, so that's how this looks like. And the same thing we would need to do up here in the send transaction with a version transaction, except we could compile it to a legacy transaction. Anyway, let's first test if this works. Probably not because I didn't submit a sign. Also, I didn't send it at all. So connection send transaction, this versioned transaction. See, that's not deprecated anymore. And then we also log this. Let's see if that will work. I would expect no, because I didn't provide my signer. Signature verification failure, yes. So either I say transaction.sign with my signers, or I think I can also provide them here. Signatures. Oh, that's manual signatures. That's a different format. If I had them already, no. I sign this with my key pair. Cool. Let's try that again. Pending. Haha. Haha, I didn't await, but it seems to have worked. Let's try it again and await this. There we go. We got the signature. And when we look at this on chain, we now see it's a version 0 transaction, which doesn't look too nice here actually, but you know, 0, just like 0, like the 0th version, because we have 0 and legacy. Obviously, that's how we name stuff. It's not 0 and 1, because that would be confusing. It's legacy and 0. Okay, and we still didn't use the lookup table though. I mean, we now have a version 0 transaction, but we still just used the account token program. That's all we did. And we sent 1 token to here. Now this guy should already have 2 tokens, except Phantom is slower, doesn't want. Ah, it shows it in here. Okay. Wow. Okay, so we still didn't win anything because we're not even using the stupid lookup table. That's true. I didn't even put the lookup table anywhere, right? So how do we now use the lookup table? When we compile to v0, we can provide a lookup table account. Address lookup table accounts, or we can even provide several, but it's gonna provide 1. Okay, address lookup table account. Address lookup table account. Key and state. Key might be probably the public key where it is saved, so that would be my lookup table. And then state, what is that? Address lookup table state. I don't know what that is. Okay, cheating again. Connection get address lookup table. Okay. And that would probably already decode it and then know where my transactions are, so I don't need to manually map. That would be nice, I guess. Lookup table, this gives me a lookup table account, yes. Type dot value, still not. If my lookup table is not present, then I shall say console log could not load lookup table return. Okay, now we provide the lookup table as well. Let's see if that also still works. Yes, 2E. We get a signature and we look at the signature. It's again a version 0 and we have address table lookups here. Sweet. So this time it decoded this account from the address lookup table. Yes, it made an address table lookup, and now all my 3 tokens are gone. But that's fine because now it's working. Cool. Back to my fee redeemer, because this video is definitely not long enough. We have 32 empty accounts here. Let's try and close them all at once. And I'm afraid that's gonna work because we can have 35 all at the same time. But since I also provide the program, well, let's see. If I could close them all at the same time and that would work, then my config is definitely messed up. I'm now asking myself if I can even do this, because if the wallet adapter doesn't have the functionality, then I can't do version transactions on that yet. We will see. Anyhow, first, the problem. The problem, if I were to do 32 at the same time, if I were to change my code and say I do 32 at the same time, and I would do it now in 1 transaction, now I have 33. How did that happen? Fine, then I do 33 at the same time. Cool, 1 transaction. So if I redeem, well, that button seems dead. Let's refresh again. I love this application. It's a great application. It works every time. Let's say I'm greedy as well and I redeem, because there might be other errors with that. It will fail to simulate on DevNet. I'm gonna approve and then it says failed. Let's see if we can get details on that. There, that's the problem. Transaction too large, 1,500, and I can only have, 1,232. That's the problem. Now, the fix is to use an address lookup table. And I'm gonna be honest with you, I'm very afraid of updating the version of the fee redeemer because many things will change. But let's see. Here I'm just building transactions. This I can leave the same. And I'm afraid that I won't get the new, that this doesn't have a version of that. A version, yes. I'm not sure how far the wallet adapter has this functionality yet, because I'm complaining that stuff changes all the time, but then maybe now I'm complaining that it didn't change. This is very old code though, very, very old. Breathe. Meanwhile, let's create a few more, just because it's fun. Don't wanna update anything, because then it breaks. Getting the connection from somewhere else is possible, but the wallet needs to sign. That's the problem. But okay, this might have been updated, the wallet adapter React. So let's update this. What could possibly go wrong if I just update this? Oh, I think as soon as I do this, I will now get problems with the packages. Oh no. Now it will think it's a module. Ah. And then I will not be able to fix this because I don't know how to JavaScript. Oh man, I think I'm just not gonna do this. Oh no, and it's getting red. No. Now I'm at like 95% that this doesn't run anymore. Oh no. Module pass failed. Okay, but I mean, that doesn't even look too bad because that just means that the library we just updated changed, right? So where is the issue now? We need an additional loader to handle the result of these loaders. What? What even does that mean? But look, it has version transactions. So the wallet adapter supports this. But okay, I think I'm gonna give up on this one because I've been playing with this for 4 hours already. But I don't want to give up completely since we do have, oh yeah, because it doesn't compile, that's why it doesn't start. But anyway, we do have a few token accounts to close. Let's look at it, I don't know, here then. SPL token accounts. Look, we have a bunch of token accounts to close. So at least I want to write a script to close all of those in one transaction, okay? Because you can't do that with regular transactions, just can't. But with lookup tables, we can do this. So what I want to do is create the lookup table, which should return me the public key of the lookup table and should receive as well the accounts, which are just public keys. Return lookup table address. Well, first, we need to find all TAs to close, which should return me a list again of public keys, and then return mints. Okay, let's see if that works. Actually, that's not mints, that's TA. Did I call that mints? No, that's not even the mint. Andy, you stupid. It's token accounts, and that's the token account. Or is it the mints? That's true, that's the mint. But I don't want the mints. I want the token accounts. Just the pub key of the account. I don't need the mint. Right. Version redeem. Let's see. Cool. We have 63 accounts to close. That's cool. Next up, we create a lookup table with those accounts. Create lookup table. Then we have the lookup table. And then I think we need to wait for a slot. How do you wait a slot? I don't know. But a general wait for half a second should be enough, right? Not 100% sure if I need that, but we can do it anyway. And then we're gonna create a bunch of close instructions. Create close instructions for my key pair and the accounts. And this is giving me a transaction instruction array promise. No promise, we're not async. So for each, actually I can just map it. That would be the cleaner way to write it. I mean, that's one line. I might have as well put that, why did I make a function here? Anyway, we have a function. Send. When we create the lookup table, let's also do this with a version transaction, just to practice. And we copy code. Great, great, great solution. Don't do a lookup table for this one because we just create one. Okay, we have a version transaction that we sign for with my key pair. Okay, now I think I don't get around getting the get address lookup table. We'll just have to await this. That's okay. So my instructions are now the instructions we get from here. Oh, because that is already an array. And the recent block hash, we just get one, and then we compile it to a v0 message with a lookup table. That's the important part here, because without the lookup table, this will not work at all. In fact, this will so much not work that I kind of want to do it that way. just to show how much it doesn't work. And then we send transaction and get, okay, and that's it. Let's see. Let's just wait. We also need to call it. Hold on. We of course need to call instructions is create. And then once we have that, we can say send v with lookup table, our connection, our instructions, my key pair, and the lookup table. And then we're done. Let's see. Ooh. Boom. Encoding overruns uint8 array. What? Probably this is the error even before telling me that the transaction size is too big, because we have a uint8 array for the transaction and it tries to encode some stuff, and because there are so many instructions in there, when we compile it, it just doesn't fit. Okay, so let's not do that, but do it with the lookup table already. See if that would work. Nope. Okay, so my error is, oh wait, that's even at the create lookup table already. Can I compile to legacy and see if that would work? Also out of range. But yeah, it has something to do with the transaction size. So it must be between 0 inclusive and 1, 2, 3, 1 inclusive. Then it received 1, 2, 3, 2. Okay, so that's probably just the next one. Probably wants to write more. Why are we out of range here? What are we trying to do? Oh, we are trying to extend. We are extending so much that obviously we can't extend that all in one transaction. Okay, I need to split up the extend then. But it was good to just see those error messages, because that's how we learn, right? That's how we learn what it all means. And so this is how we need to split it now. We still need to send several transactions, but now we just split the creating of the lookup table into several transactions. So we don't really save much, right? But we can then do one big atomic transaction. Is that worth it? Well, probably not for the fee redeemer, but for other things. This is also just learning and not being super productive. So anyhow, if I were to, just to prove my point, if I were not taking all the accounts, but just the first, I don't know, 20, then it should work. At least that part, and then it will fail later. Yeah, so that part worked, but then it can't load the lookup table. Well, obviously, because, hold on, why obviously? There should still be a lookup table. Maybe we didn't wait long enough. We created one, extended it with a bunch of data, right? And see, this is the problem. We need so much instruction data to write all the accounts. That is then just too big to put it all in one. Fair enough. How many can we put into one? Probably 36, because that's a nice number. Nope, 36 is too much. 35, 33, 30. Yep, 30 works for fun. Try 32. Nope. But this time we get a different error. Version transaction too large. So this time the buffer was not too small, but the transaction overall was too big. 31. I'm trying this out for you so you don't have to do this. Okay, so 31 is still too big. So 30, which is a nice number, is the maximum of accounts that we can put into the address lookup table at once. Good to know. So with 30, it should now work again though. If I get a proper slot. Invalid account owner. How about we just wait just a bit after creation? Still invalid account owner. Okay, maybe we wait longer because the simulation failed, so it doesn't already know that the thing is there. Maybe that's the issue. But it worked when I put it in the same transaction. Whoever edits this video, I need to pay them a lot. So one last try with 30 seconds. Okay, so it was that. That was the issue. Just the extend now works. I just need to wait for this to be there. So we just extend with a bunch of data. Yeah, okay, fine. So I mean, the better way to do this, how do I put a commitment? That was already last time my error. I don't know how to put a commitment here. Never mind, we just wait. or we do it once and then we just extend. But the way we would now properly extend is to do this in a loop. And we do this and this in here. Slicing from I times 30 to I plus 1 times 30. Yeah, then we send those transactions. Could also happen now that I still need to wait more time between those. I'm not sure how the address lookup table program works. If I just send it that and then another one, do I already know what the offset needs to be? I don't think so. I think the address lookup table program itself can deal with that stuff. So I don't think I need to wait between those. And I think it should just be 3 transactions because we have a bit more than 60. 1, 2, 3. Yes, cool. They all went through. Amazing. Then we get some other problems. Okay, but that's cool. We created a lookup table. Maybe we should also lock this stuff. Then we will wait another slot until we send with the lookup table. What's now the problem? It's not the get lookup table, right? No, the lookup table is now there. That works. We waited long enough. That was also the problem for why it was printing that message. The RPC just didn't already know that it's there. But now it is. And then we have the same problem because we say encoding overruns uint8 array. So the buffer is too small because, well, we try to add all the instructions without the lookup table. So now we do it with the lookup table and see if that works. All in one. Let's just do it. We're so close to the end. This is not a recent slot. Yes, yes, yes. Of course it did. Okay. Creating the lookup table worked. 3 more for extending it. 1, 2, 3. Boom. The lookup is there. And boom. Damn it. We still get that error. But the lookup table, that one is already here. And it's cool. We actually never looked at that. It says it's active. We see the transactions. That's where it was created. That's where it was filled. We could play around more with like deactivating and then closing it. But I guess that's self-explanatory enough that I don't need to do that. You can play with that yourself. I want to find out why we still get a range error. So first of all, where in our code do we get that? When we sign it. So it's still too big. I mean, we said we get factor 8. We should still be able to do 100 accounts at least. Yes, 20 times 8 is 100. That's how maths works. I don't want to do this anymore. It's the entire day. I thought I would make a quick video in 2 hours. There is no quick in Solana. Well, yes, there is. There's quick now. It's replacing UDP, yo. Why? Okay. First of all, I don't want to always have to wait 30 seconds. So we're going to change this a bit and just use that one that we just created because it's still active. Then the rest. Let's see if that gives me the same error. Probably. What? Oh, I get it. It does not give us the same error because we were just not waiting long enough because that was too short for it to actually understand what is all written in the lookup table. So the last extends were not like it didn't know that when I did the get address lookup table. So in there it didn't have all the information to make the lookup table, like the lookup small enough. And so I just had to wait longer. And when I wait longer, then it actually works. And it creates a transaction and it's done. Wow, okay. Okay, look at that transaction now. We have a version 0 transaction and look at the amount of accounts that I have in one single transaction. I have 65 accounts in one single transaction, and I close all of the token accounts. Look at that. Like, there's so many. Yeah. Look at that. Look at that. I get a close, 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 another close, another close, another close. So many closes. So many closes. Look how many closes there are. Look. 63 token program close accounts in one transaction. This is so much that the Explorer even decided, oh, I can't be bothered to show you the details anymore. Oh man, this is fun. This is fun. There's a lot to scroll here. I love it. I love it. Look how oh, this was the goal of today, and we finally achieved it. We finally managed. Look, we get 0.128 sol back from closing all of those in one transaction. So cool. So cool. Okay, I mean, to wrap it up, to get even more sol back, let's do the closing, because, I mean, it can't be so hard now. We have a lookup table and just want to close it. Let's ignore all of that. Deactivate lookup table. You need the authority and the lookup table. Well, that's simple enough. So that's my key pair and the lookup table address. And that is, again, a instruction, and the same thing for close probably. What does the close need? The close needs the authority, the lookup table, and who should receive the funds. So same, my lookup table is this, and the recipient should also be me. Just for fun, let's just try and send this one. Wait, I had a helper function for that, send v0. So let's just try and close it. Let's just see what that says. That should tell us something like you can't close because it's still active or something. Lookup table is not deactivated. If we try to do it both at once, so we do the deactivate and close in one transaction, probably gonna be the same thing. This one was success. But then this one, an invalid program argument. Anyway, so the transaction failed. That was my lookup table. It's still active. So I would need to do the one and then wait a bit and then do the second. Let's just deactivate it. That transaction went through now. If I refresh here, then it now tells me it's deactivated. And if I then close it, still doesn't work. Table cannot be closed until it's fully deactivated in 501 blocks. Okay, good to know. So that's how long it takes to until we can actually deactivate it. 501 or 501 more blocks. Yeah. Now it's 423 blocks. So we get an idea of how quickly that happens. I would say like several minutes maybe until we can actually close it. So doing this in one function, forget it. We need to wait quite a long time until we can actually close it. Only 355 blocks. But it's cool that the error message tells me how many blocks left. Yeah, I see the last extended slot, or that's where it was. Oh, but that's the last one where I added something. Last extended deactivation slot. No, there's a separate deactivation slot for it. 127 blocks left. All right, so yeah, several minutes, like 5 minutes. You gotta wait until you can close it. And then we can't create it with the same address anymore, obviously, because we can't use the same recent blockage. People who developed this thought about that. I like that. I mean, it's complicated and I like it. 32 more blocks. That's 32 times 500 milliseconds. So approximately 16 seconds. So that should be over now. Probably made a mistake in my calculation, but boom! There we go. Closed it. Closed it. Now if I refresh this, it should be gone now. Yeah, it's an empty account. There's nothing here anymore. It doesn't tell me that it has been an address lookup table, but it tells me that there were previous transactions on here. For instance, this one, the one that I just copied. Oh no, that was the deactivation 4 minutes ago. And this one I just copied. This one, the closing. There, that's the closed lookup table. And here we get 0.015 sol back. Yes, because this is being cleaned up. Nice. Nice. All right. All in right. That was a long endeavor today. But I hope that you learned something. I certainly learned a lot of stuff about address lookup tables and version transactions, because it is an interesting topic and it might be an important topic for understanding how transactions work, right? This is so basic, and it opens up like a lot of opportunities for making transactions use more accounts. You might want to do that. Of course, it's more complicated than the legacy transaction, and it's annoying that we now need to always do the message whenever we create a transaction, and the good old stuff is being deprecated. But I mean, just looking at this makes me so fucking happy. It's how many things you can do. Yeah. It was a pain to build up the address lookup table, yes, because we needed the few transactions there. But then we can now have like 250 accounts at the same transaction. So cool. Yeah. All right. And with that, I want to end it for today. Has been way too long. I'll see you in the next videos. Go check out those. Like the video. Check out the Solana development course videos that I do, where we go over the basics. This is already very not so basic anymore, and at the same time super basic, but you know. Yeah. Okay, cool. I'll see you in the next one. Bye bye. I now need to go rest.